Okay. Hi, guys. I'm Anne-Marie. So I'm going to be your tutor for this semester. I'll be holding these review sessions every week, and we'll have one on Sundays and then also Thursdays like this one. So thanks for stopping by. Let me see. Can you guys see my, this is the first time I've used Zoom. We used a different one last year, or last semester. So can you guys see my screen with the Penn State Learning logo on it?
Yeah.
All right, cool, perfect. All right, thank you. So basically the setup of these sessions is going to be that we will like go through that week's content and we'll just talk about it, kind of review the information, and then I will have some review questions at the end that basically we will go over, and then there'll be time for questions if you guys have any questions at the end. And I also have Q&A sessions that you guys can stop by. Basically, that's going to be like an open session for you guys to just ask whatever questions you have. That doesn't have anything like set up. That's totally off of your guys' questions and what you have. So yeah, feel free to stop me at any time if you have any questions throughout. If you have more of a specific question, maybe hold it till the end just so we can keep moving in case anyone, just not to halt it and make sure everyone gets through what they have to. What else? But yeah, stop me at any time. You guys can either use your mic or you can type whatever you're comfortable with. And thank you for everyone who put in their Penn State ID, your email address in the chat box. We're not going to email you. We're just using that for attendance reasons. So, but yeah, so like I said, just let me know if you have any questions. So we'll go ahead and get started for this week. Like I said, this is my first time using Zoom. So if something's going wrong and you can't hear me or something, please let me know because I know I'm going to mess it up at some point. So, all right, so let's start here with, so basically this is just a review of what I just told you guys. So let's get this. So, all right, so this week we just are kind of giving you that introduction of what statistics is all about. So we'll have like cases and variables. So variables are kind of like the basis of statistics, but if we're going to compare them, cases are going to be basically the information we used in a research study. After we collect all that information, that's going to be our case. And we also call them units, experimental units. And then if we compare that to variables, those are going to be the things that we measure, and they will take on different values at that point. And that's why they're called variables, because they vary. Another way to look at it. And then constants, stay constant. So that's more of a way to look at it. So what else? Okay, so then we have two different types of variables specifically. We'll have categorical variables and also quantitative. So our categorical variables are going to be things that don't really involve numbers. They're going to be things that have labels or groups. And so then there's two different types of categorical variables. So we can have a nominal categorical variable, and then we can also have an ordinal categorical variable. So nominal is more so just talking about a categorical variable that is a label, but it can have any order. So I always use examples of like colors, like brands of like anything like cars, clothing, any of that kind of stuff. So yeah, they can be in any order, but remember they're still labels. They don't really have any like value attached to them. An ordinal kind of sounds like order, so there has to be some sort of order to it. We have to have a hierarchy. So these can be things like if you're labeling college students and their years, like freshman, sophomore, junior, senior, that is an option there. So that can be ordinal. Basically anything that has a hierarchy, but keep in mind it still has to be labels. It's not going to have values attached to it like 1 to 10. It's going to still be those labels. For for quantitative variables, those are going to be variables that have numbers attached to them, so different values. So, you know, 1 is going to be less than 10, obviously. Then 2 different types of quantitative variables. We do have discrete and continuous. So discrete is one that can only take on a set number of values. There can't be like halves or anything. So we think about like people. You can't have like 1.67 like people. So that would be a discrete variable. You can only have like whole numbers. So those are options like that. Cars, houses, stuff like that. You can't really split up. And then continuous are going to be variables that kind of can have any number on the number line. So I think things like weight, height, any type of measurement in that case. Quantitative variables are also known as measurement variables, but yeah, continuous ones are going to be able to take on any value in that case, and they're not going to be like, it doesn't matter if they, you know, they don't have to be specific whole numbers. They can, because you can be like 150.42 pounds, you know, it doesn't have to be exactly a specific number. So that's where what variables are. Okay, so then we also, if we're talking about variables in regards to like how they relate to each other, we have our explanatory variable, which explains the response variable. So explanatory kind of has that explain part to it. Sorry, I'm going to get my little notepad out here. Okay, and our response variable is going to respond to our explanatory variable. So we also call that the outcome variable because it's going to be whatever the outcome is. And then we talk more about independence and dependence. So our explanatory variable is going to be the variable that's independent, and so nothing affects it. So if you think about like if you're an independent person, you know, no one's going to affect you, so something like that. So that's how I think of it. And that's going to be what's predicting the outcome. And then our response variable is what's explaining, or that's going to happen after our explanatory variable, and that's dependent on whatever the explanatory variable is. So our response variable is going to change in regards to what the explanatory variable is. And we'll go over some examples of that, but that's just the base of what these things are. And just to kind of go a little bit farther into to understand independence and dependence. So independence is saying they're unrelated. There's really no connection between the two. You know, one thing doesn't affect the other. So that could be things like the weather in Pennsylvania versus the weather in Florida. They don't really affect one another, so they would be independent of one another. So things like that. And independence usually comes from randomized comparative experiments. That's, you know, if you're comparing two different things, two different conditions, that's when it's a randomized comparative experiment. Those are going to be independent variables. So yeah, they don't affect each other. And then dependence is, so some examples of that we'll get into later on are going to be our paired and match paired samples. And that means that they do affect each other. What happens to one can influence the other one. So one prime example that we'll talk about a lot is like, you know, like maybe like how much studying you do and your exam scores, or like your midterm scores and your final exam score. You know, like they do affect each other depending on what happens to the first one. The next one is going to be affected by that. And many times the subjects are the same in both groups. So that's an example with the midterm exam and the final exam, because you're looking at the same people, but just at different points in time. And you're looking at, you know, their different scores. So that's what we mean by that. They are the same in both groups. All right, so now we're going to talk about samples and populations. So I kind of drew this out, well, typed it out, I guess, in a way that it's the populations is the top here that I have. This is going to be, you know, this is like our umbrella term, basically. And then I'm going to draw it into an umbrella. That's really nice. Okay, so we have this here, and our population parameters, that's our overarching situation that we take our samples from. So, and this is fixed, so this is saying that it doesn't change. This is not variable, because our samples that come out of it if the population wasn't fixed, then our samples wouldn't be very useful. So our population is going to be whatever the entire situation that we're looking at is. And then our samples are going to, and then parameters and statistics, those are basically the way that we describe the actual measurements that come out of population and sample. So like a parameter is the actual measurement of a population, and then a statistic is the actual measurement of a sample. So yeah, it's basically that group that you take from the population, and that's going to be what we collect data from, because it's very difficult to collect data from an entire population. You know, you can't collect data from the entire United States or any, you know, country, that kind of thing. So using different samples is a better way to make it more feasible, and that's basically what we choose from the population. So it is variable. They do change, and we use them to make inferences about the population. So the way I usually think of this is that we take our sample from the population, and then from the sample, we make inferences about the population. So that's how I think of it. It's kind of a cycle. You know, we start with our population, we take a sample from it, and then whatever sample we have, we're using that to make an inference about our population. So it's some sort of cycle. So maybe think of it that way if that helps you guys. Okay, let's see. Okay, now I have to stop annotating. Okay. All right, cool. Oh, it keeps it there. See, that's what I'm talking about. I'm gonna, oh my. All right, clear my drawing. Oh, okay. All right, we got it. So, so these are different sampling methods that you can use. So simple random sampling is basically, it's one of the most common ones. It's basically just taking samples and you're not replacing them. So after you take that sample, that stays out of your population. So if you have a population of, if you have a population of 100 and you take a sample of 10 out, your next sample is going to come from a population of 90, and then so on and so forth. Equal chance of selection, that means that the probability has to be the same for each of these, and whenever you're making this selection, there can't be any sort of bias in that case for it to be a simple random sample. And then convenience samples are kind of not things that we don't want. So our convenience sample is going to be something that we basically just use whatever we have access to. It's easy. It's the easiest thing we can do. It's not random. So a convenience sample could be, for example, if you're, you know, trying to find out information about your entire college, but you interview your roommates. You know, it's like that's a convenience sample. You know, they're part of the college, but that's not going to be very representative because it's just the easiest thing you have. And, you know, so it's not going to be that representative and give you information about the population there. So that's not random either. You're not taking random samples, you're just taking what you have there. Okay. Oh, a little dot there. How do I stop annotating? Oh, here we go. Okay. All right. So like I was talking about, we can have bias if we do convenience sampling, and basically any type of bad sampling method, we can have bias in that case. So we want to have a representative sample. So that's saying that whatever that sample is that we took, so we have our population, and then whatever sample we took from that population, we want that to represent our population. Because what our sample is what we're making inferences about. So if that sample doesn't represent our population, it's not really going to give us good inferences. So basically, your sample is like a tiny population, if you think of it that way. So we want it to look like the population, but it's just not going to be as many members of it. So if we have sampling bias, then it's not going to be representative. It can favor certain outcomes. So this would be bad sampling method. For example, there's different things that you read about in your notes, like non-response bias would be like if you sent out a survey and it was about maybe something that has to do with like nutrition, and maybe the only people that are going to respond are people who are like passionate or interested about nutrition. And then people don't respond are the ones who don't really care. So that means that your sample that you got isn't going to be very representative because it's only representing the people who care about nutrition and answered that. It's not representing the people who don't really care. So you would want that to include everyone because the population is going to include people who care and don't care. So that's something that is difficult when you're doing a survey, that people kind of have the option to send back. Response bias is basically going to be when you are favoring certain outcomes, like people who I use the example of, like, if you are talking to a professor and they're doing a survey on whether or not you've cheated in their class before. So usually people are going to say what they think the teacher wants to hear. They're always going to be like, no, I've never cheated, but they might just be saying that because that's what they think they should say. So they're not being truthful. So their response, so this is response bias, because their response is not representative of what's actually true. So yeah, that's basically bias. Okay, this is just a point that we'll bring up a lot throughout the semester. Causation is not equal to association. So when you find when you make a conclusion about a population, just because they're associated doesn't mean that one causes the other. You're just finding some sort of link between them. So if you make a randomized experiment, and it's randomized, and you did everything correctly there, we can make a causal conclusion. So we're saying that there's some sort of cause going on between the differences in the explanatory variable. But if you don't do randomization and you find an association, you can say there's some sort of association between these two, but you cannot say that one causes the other. So we can't make that conclusion. So we can say there's a relationship, but we can't get into we can't be saying that one causes the other. So keep that in mind. Causation does not equal association. All right, so we have different types of studies depending on what we're doing with the variables. So we have experimental studies, and we also have observational studies. So our experimental studies are going to be those in which the researcher imposes some sort of treatment. They're manipulating the variables. We also call it a scientific study. So this would be if the researcher is, let's say they're doing a study on rats, and they feed half the rats, a certain type of food, and the other half a different type of food. That would be an experiment, because they're imposing a treatment upon them. They're imposing what type of food they're getting. And this is a good thing to control for confounding variables. So remember, confounding variables are just variables that's related to what the variables that we're looking at, but it's not what we're trying to find in the study. So in that case, it's just like it's related to the variables of interest, but it's not what we're looking for. So it can skew our results in that case. So just to make sure, like a way to control for these would be that the participants are going to just randomly assign the different levels of these explanatory variables, which is randomization. So remember when we talked about randomization, making sure that that's going to be representative, that's going to be able to control for those confounding variables. And then observational studies are different in the way that you're basically just observing your variables and your participants. You're just checking, taking notes and data on them without imposing any sort of treatment. So I liken this to like people watching. So if you're at the mall and you're just people watching and seeing what's going on, and maybe you're counting the number of women who have a purse, or the number of men in the mall, or something like that. In that case, that would be an observational study, because we're basically just looking at what they're doing without imposing a treatment. You're not imposing any sort of treatment on the people in the mall. You're just kind of seeing what's going on. So this runs the risk of confounding variables because you're not controlling for it. The experiment isn't randomized, so something like that. Okay, so let's see what else. So if we have our control group, that's going to be our baseline. So these are about experimental studies. So our control group is going to be the group that doesn't receive any treatment. And then we also have an example of a control group would be the placebo group. So they're not receiving any treatment, but they think they are. So that would be if you have two different types of groups taking a pill, and half of them are going to take the actual medicine, the other half are going to take a pill, but it's going to be a fake pill that doesn't do anything to them. That would be a placebo group. So that's their control group because that's our baseline. And then blinding would be, these are things that involve what the researcher knows and what the participant knows. So single blind means that the researcher splits up the groups and gives one group the placebo and one group the medicine, but they don't know which treatment they're in. Double blind is going to be when the participants and researchers don't know what groups are assigned. So they're both, half the group is assigned a placebo, for example, and the other half the actual medicine, but both the researcher and the participant have no idea of it. So this does make sure that there's no researcher bias, because if, that makes sure that they don't know what's going on, so they can't choose a group to receive more treatment than the other. All right, so we're going to do some review questions. So basically the way I work these is just, I'll go ahead and read the question, give you guys some time to respond. You can go ahead and type your answer in the chat box when you're ready. And if you haven't done so already, if you could put your Penn State email into the chat box, that would be great. And so yeah, so let's go ahead and try this one. So we have a research question. It says, do 6-month-old babies who are being breastfed weigh more than 6-month-old babies who are not being breastfed? So data were collected concerning 10,000 6-month-old babies. Whether or not the baby is being breastfed was recorded, as well as the baby's weight in pounds. So which of the following statements is true about this study? So go ahead and read through those and let me know what you think. Okay, good answers. No question marks. Be confident in your answers. If you think it's that answers, no question marks, you guys. So the answer to this one is going to be B. So let's kind of go through all the options and kind of see why it would be B. So first of all, this A is saying the study does not have a large enough sample size. That's not true because it does have a large enough sample size. Our N is equal to 10,000. That's a big sample size. So that's not going to be the right one in that case. So A, we can cancel that one out. C says that the group that's breastfed is the placebo group. That's not true because remember, a placebo is going to be the one that's not receiving the treatment. But there's not really a treatment going on here. It's just kind of observing those who are being breastfed and those who are not. They're not making sure, they're not checking to see that, okay, yeah. So we're asking what is true about this study. So yeah, D would be, if we go to D, they're not controlling whether or not they're being breastfed or not. They're just observing, so they're seeing, so there's dang it. so we have those, all the babies, and then all they're doing is seeing if they're breastfed or not. They're not telling the moms like, you breastfeed your child and you don't, that would be imposing a treatment. But in this case, they're just observing. So yeah, this isn't an experimental study. It's actually an observational. And then for C, the group that's breastfed, like I said, the placebo group, that means that they wouldn't be imposing a treatment, but in order to have a placebo group, it would have to be an experimental study, and since it's not, it can't be C. So B is the correct one because there is no randomization. They're not randomizing who's being breastfed and who's not. So basically, that's why the answer would be B. Does that make sense to everyone? Woohoo. Cool. Yeah, I know. Last semester, everyone would be like, it seems so easy after you explain it. And I'm like, well, yeah, I guess that's the point. But don't be afraid to answer the questions. I throw some in here that are challenging. If you don't know, tell me you don't know. But this is a safe space, and I want you guys to ask questions. If it doesn't make sense after I explain it, please ask me again. I'm more than happy to explain it again. Like, don't let me move on if you don't get it. But good, perfect. So we'll go ahead and do the next one, if I can find it. Why does it do this? Okay, let me clear my drawing. Okay, here we go. All right, let's do another one. So in the fall of 2015, there were a total of 508 undergraduate students enrolled at Penn State Shenango. Of those students, 204 were enrolled in associate's degree program. So here we have they did the 204 students enrolled in that associate degree program divided by the total number of Penn State undergrad students to get 40.2%, which is showing us that 40.2% of all Penn State Shenango students were enrolled in an associate's degree program in fall 2015. So which of the following options is best describing the value of 0.402? So go ahead and read through these and let me know what you're thinking. Okay, so we're all over the board here. Okay, so the answer is actually D. So let me just go back to this one slide quick to review this. Let me see how I can. I don't know what I'm doing. All right, let me just back this up. Now there's a circle there. Oh my god. Okay. Let's just ignore that. Okay, so let's look back at this. So populations are always going to be associated with parameters. Like these two words are always going to go together, and samples and statistics are always going to go together. So, I mean, you can look at it like with the S and the S and the P and the P. So you're never going to have something like a population statistic or a sample parameter. It's never going to be a thing. So if you see population, if you're talking about a population, your measurement is going to be a parameter. So you want to, if you know that you're measuring that population, that's going to be a parameter. If you know that you're measuring a sample, that's going to be a statistic. So let's, oh my gosh, stop this. All right, let's go back to the question. Oh my gosh, this is actually ridiculous. All right, so, yes. Oh, Oh, sweet. I can undo. That's cool. All right. So if we go back and use that information, A can't be correct because population has to go with parameters. So you can't have a population statistic. This just isn't a term that you would ever see. So A is not correct. And then C is not correct either because sample does not go with parameter. It goes with statistic. So that's not something you would ever see. So that's not true. So our options at this point would be population parameter or sample statistic. So we're talking about this value of 0.402. So we took, this value came from the population. So our population would be that 508. So good job, Roger, that's correct. That would be 508 is our population. But we got this 40.2% from that population. So remember, when we have our population, whatever we get out of it is going to be our sample. So we have our population, whatever we take out will be our sample. So our population here was 508. And then our sample is going to be 40.2% who were enrolled in the associate's degree. So this 40.2% is what we took from the population. We're taking a sample of who was enrolled in the associate degree program out of that population. So in this case, this 40.2 would be a sample. So our answer would have to be D because it's not a population parameter because this was changing. This was the amount who were enrolled in the associate's degree program. If that were to increase, that would be variable. So it couldn't be B because we're not talking about a population. So the answer would be D. Does that make sense? You are welcome. So nice. Thank you, me. Oh. Of course. Oh, you guys are so nice. All right, cool. And like I said, if it doesn't make sense, please ask me. I want you guys to understand, and it's good that you guys are coming to these. That I've in the past, everyone who comes to these definitely is very successful on their exams and everything. So, just a good review. But all right, perfect. So let's clear this if I can. Okay. Let's see. Let's do a few more. I can switch the slide. All right. Nope. Okay. All right. So here's another. So a school psychologist wants to use students' intelligence test scores to predict their reading comprehension scores. She takes a sample of 100 students and records each individual's intelligence score, test score, and reading comprehension scores. So in this scenario, what is our response variable? Let's go ahead and read through these options. Okay, good job. Perfect. You guys definitely understand this concept. So yeah, our answer here is C. I won't harp on this one too much because you definitely get it. So our response variable, remember, is the one that's going to be dependent upon our explanatory variable. So if we go ahead through this and we think about it, they're trying to see if our intelligence scores predict the reading comprehension scores. So that's something to keep in. This is the word predict is a good way to check to see if you have like your explanatory variable and your response variable. So usually whatever is first that's being used to predict is going to be our explanatory variable first, which is being used to predict the response variable. So in this case, intelligence test scores would be our explanatory variable, and then you guys are correct that our reading comprehension scores are going to be our response variable because oh yeah, get ready. I know the fun. Yeah, you guys will be set. Don't worry. This class is challenging, but if you stay up on your on the information, you'll be okay. I passed it, so it's okay. I took it too. I mean, a while ago. I took it my freshman year, and I'm a senior now, so I'm a senior. I'm crying. Okay, so yeah, basically, so yeah, whatever is being, it was dependent. So our reading comprehension scores are dependent on the intelligence test. So A would not be correct because that's just our sample size, and B we just said is our explanatory variable. Clearly, I can't spell explanatory. And then this is our sample size. And then D, the relationship between the scores, that would not be a response variable because it's not a relationship. So D would not be right. So our answer is C. Good job, guys. Perfect. All right, let's get rid of this. Oh, no. Stop. SOS. It's not weird. Okay. Let's go. Okay, I think this is the last one I have. Okay. All right, so yeah, one more. So here's our research question. So can the age of a child in months be used to predict his or her vocabulary? So we collected data from a sample of 500 ranging in age from 12 months to 60 months. What is our explanatory variable here? Okay, good questions. Yeah, great questions. So our explanatory variable is predicting our response. So that's why I was saying the last one where if you look for that word predict, whatever's before it is going to be your explanatory because it's predicting your response. So our explanatory variable, remember, it's independent, and that's going to be the one that explains. So, explains, predict, those are, in this class, vocabulary is a big thing, and the more practice problems you do, the better you're going to get at it. So if you, see the word predict or explain, that can kind of lead you in the right direction of what type of variable it's going to be. So if we go through this and look, remember, so we have predict here. Where's my, oh no. Okay, we back. All right, so let me annotate. Okay, so yeah, used to predict. So age is being used to predict the vocabulary. So age is going to be our explanatory variable because it's explaining something, which in this case is going to be the vocabulary. So that's going to be our response because the age is explaining the vocabulary. The vocabulary is dependent on the age. The vocabulary is in response, is our outcome, dependent on the age. That's another thing. It's dependent on it. So it's a dependent variable. So yeah, so our explanatory variable, remember, it's explaining our response variable. So we discussed here that our vocabulary is going to be our response. So that's not the right answer. The range of ages, that's just not That's just not the answer. The range of ages would not have to do with anything really. And then 500 children is going to be our sample size. So that's not correct. So then A would be correct because that's our age in months, because that is what's explaining the vocabulary, our response variables. Is everyone clear on that one? Woohoo! Raise the roof. All right, cool. All right, so let me, oh man, hopefully I get better at this Zoom thing in the next session, because I am just, woo! All right, next slide. All right, so that's all we got for tonight. So you can, actually, this is incorrect. This is from last semester, so don't look at this. Ah, what? No, go back. You're very welcome. So what you can do if you want to watch this back, is, wait, let me cross this out because this is not true. You actually want to go on my YouTube channel. I feel so cool. I have a YouTube channel. It's not like it's exciting. It's just going to have these recordings on it. But it'll be youtube.com/stat with Anne-Marie. That's me. And this is also on the notes page if you guys want to go ahead and check that out. That will be that'll give you all the links to the review sessions that you can do. So yeah, I will upload that right now, right after this session. So our next session will be on Sunday, the 27th, at 10 again. Tomorrow we'll have a Q&A from 4 to 5 p.m. if you have any other questions. If you have questions now, you're more than welcome to type them in the chat box, or you can wait till tomorrow. But yeah, that's all we got. So thanks for stopping by, to anyone who's done with me and wants to leave. And hopefully I'll see you at another session. Woohoo, cool. Yeah, come by, because if no one comes by, I'm just going to talk to myself and make a recording by myself. So I've done it before, and it's horrible. I start off, and I'm like, do I say, hey, guys, like, because there's no one there. So I'm like, hey, no one. So definitely come by and hang out. Hopefully it's helpful, and, you know, we'll have a good time. All right, cool. Yay. And I like criticisms. If you guys think, you know, there's anything you need, you know, for me to do better, any extra things you guys want, let me know. You know, this is for you guys. I want to help you guys out. So, yeah, formulas are tough. I think this class isn't, this might be, it might be, I think it's more focused on like vocabulary and concepts. There are some formulas and whatnot, but I think that the better you get at understanding the concepts, and you can go through, like you can go through it and label. I'll show you, like, because I took this class, like I said, so one of the things I like to do is go through and kind of tell you how I worked this out, and, you know, what happened to me. And so, you know, I'll go ahead and do all that and whatnot. But anyway, I think the class is a lot about conceptual things, and after you have it conceptually and you're able to understand that, then plugging in the numbers to the equations and stuff and the formulas is like cake. That's gonna seem really easy to you guys. So yeah. Oh yes, have hope. You guys will be okay. Don't worry. I'm gonna post the recordings right after. So definitely just, you know, give me a hot second after this, and that's my first time like uploading to YouTube, you know, so like, oh, I'm nervous, but I'm gonna go ahead on there right after this and try to do that. And yeah, like I said, you guys will have the sessions like, you know, every week, Sundays and Thursdays, and they'll all be posted, I believe. Let me just make sure here that I post Sundays. Yes. Yep. So Sundays I'll also post, and those will be good to go. So yeah. Okay, cool. So hopefully these will be helpful. In the past, everyone says they're good. So, but yeah. Okay. Have a good night to whoever's leaving. If you have any other questions, let me know. And if not, see you at the next session. Of course. Have a good night, guys.